Hi, so question 18. I'm going to do each of these little components one by one. So 5 and 4/9 to the negative a half. Before I do anything with that, I'm going to turn 5 and 4/9 into a top-heavy fraction. 5 times 9 is 45. Add the 4, 49 over 9 to the negative a half. The negative indice means we're going to flip it. We're going to find the reciprocal. So that's 9 over 49 to the half, and then that half means we're going to square root everything. So we've got 3 over 7. Okay, our next bit, we don't have to do too much of that. 4 and 2/3. Turn that into a top-heavy fraction. 4 times 3 is 12. Add the 2, 14. So 14 over 3. And then 2 to the negative 3 is 1 over 2 cubed, which is then 1 over 8. So we can now rewrite this as 3 over 7 times by 14 over 3, and then that's all over 1/8. So this top bit, we'll deal with that now. 3 and the 3 cancel, 14 and the 7 cancel, and we're left with 2 over 1/8. Now when we've got 2 over something, I like to think of it as divide, so 2 divided by 1/8, which that means we can apply keep, change, flip. 2 times by 8 over 1, and that is 2 times by 8, which gives us 16. Question 19. Okay, so for this one, this is probably not the best way to go about it. This is the way I'm going to do it. I'm going to start to remove these denominators. So by multiplying by 2x minus 1, that first term becomes 1, plus 3 lots of 2x minus 1, and that's still over the x minus 1, and that equals 2x minus 1. So all three parts have been multiplied by 2x minus 1. I'm going to multiply all three parts now by x minus 1. So x minus 1 plus, we then remove our denominator from this one. So I need a bit more space between my 1. Let's put that there. And then that equals 2x minus 1, and that's multiplied by x minus 1. Okay, let's expand it all. So x minus 1 plus 6x take away 3 is equal to 2x squared take away 2x take away x plus 1. Tidy it up on both sides. 7x minus 4 is equal to 2x squared take away 3x plus 1. And then I'm going to bring these two over. So 0 is equal to 2x squared take away 10x plus 5. Okay, looking at this, I'm not even going to bother seeing whether it factorizes because it wants it in this format, p plus minus q. I could complete the square, but I'm going to go for the quadratic formula. It's nice and familiar. So minus b plus or minus the square root of b squared take away 4ac, all divided by 2a. That gives me 10 plus or minus the square root of 10 squared, or negative 10 squared, which is 100. And then take away 4 times by 2 times by 5. 4 times 5 is 20 times by 2, 40. And that's all divided by 2 lots of a, which is 4. Next little simple bit, plus or minus the square root of 60 over 4. Now, because our answer needs to have divide by 2, it means this root 60 must have a way of simplifying, and it does. So a factor pair of 60 is 4 and 15, which therefore means a factor pair of root 60 is root 4 and root 15. And the square root of 4 is 2, so we have 2 root 15. 10 plus or minus 2 root 15 all over 4. And then we can halve all three of these terms. So we get 5 plus or minus the square root of 2 divided by 2 is just 1 over 2, like that. And therefore our value of p is 5 and our value of q is 15. Just checking the format. Happy with that. That's how we wanted it left. So we're looking good. Okay, question 20. This one's got a bit of A-level about it. First thing I'm going to do is just draw a sketch. If it's tricky, draw a picky. Minus 1, 3 is roughly there. 6, 8 will be roughly like somewhere over here maybe. That's the center point, so that's going to be like a circle. That's the radius, and then that's going to be the tangent we're looking for. So I know I'm going to have a nice positive y-intercept, negative gradient, etc. But we need to know the gradient of the radius first, and then we can flip it. So Doesn't matter what way around I do these. 3 minus 8 over 3 minus 8 minus 1 over, take away 6, sorry. Doesn't matter which way I do it. I mean, I'm just, doesn't matter which way round we are. So this is like y2, that's y2, y1, y1, x1, x1, and then x2, x2. So as you can see, those coordinates need to be on top of each other in this calculation. And then 3 take away 8 is -5, 1, sorry, -1 minus 6 gives me -7. So that's got a gradient of 5 over 7. Good, positive, happy. Next bit. So the perpendicular gradient is going to be -7 over 5 because it's 1 minus m. Then I can use, what one should I use? Use y equals mx plus c. Y equals mx plus c. My coordinate that's on that point A, is 6, 8, which means my y coordinate is 8, and my x coordinate is 6. So 6 is going to multiply the -7 over 5, and this is going to help me to work out what c is, where that y-intercept is. So 8 equals 6 times 7 is 42, -42 over 5 plus c. That is 8 equals -8 and 2/5 plus c. So that's 16 and 2/5 is equal to c. Not quite finished. So y equals mx plus c. We've got y equals -7 over 5x plus 6. I'm going to take that. Do I do it? Yeah. Okay, 16 times by 5 is 80. 82 over 5. I need to get it all on the other side because I need to put it into this format here. We need to have integers. So first thing, add the 7 over 5x plus y, and we subtract the 82 over 5, which equals 0. Now we multiply everything by 5. So 7x plus 5y, take away 82, is equal to 0. Okay, question 21. If you've got to this question, you're still standing. Well done. This one's going to knock your socks off. So the diagram shows 3 circles, each of a radius 4 centimeters. The center of the circles A, B, and C are such that ABC is a straight line, like so. And then AB equals AC, of course, because 4 centimeters. Work out the total area of the shaded region. So what we've got here is a load of equilateral triangles. And we can split this into a nice hexagon, like so. What we're going to notice is as follows. So this bit in here is going to be the same as this bit in here and the same as this bit in here. So we're going to find the value of that segment. We're going to find the value of the triangle. We're going to find the value of the sector. So let's start off with the area of the triangle. So the triangle. We've got an equilateral triangle. It's 60 degrees. I'm going to use a half AB sin C, half AB sin C, which means it's just a half times by 4, because that's a radius, times by 4 again, times by sin 60. Okay, so 4 times 4 times 2 is 8 lots of sin 60, and hopefully you've been reading up on your trig values and you'll know that sin 60 is root 3 over 2. So 8 times by root 3 over 2. 8 divided by 2 is 4. So we've got 4 root 3 for the area of that triangle. Okay, the area of that sector. So the area of the triangle, let me just put the sector. The area of the triangle is going to be 4 squared times by pi. And then we want 1/6 of it, which is sort of the 60 over the 360. 16 times by pi, or 16 pi, I should just write 16 pi, times by 1/6. So this is 16 pi over 6, which is 8 pi over 3. So 8 pi over 3 is the area of that sector. Now, to work out the segment, and that's going to be one of these little bits in here, the area of that segment is sector, take away triangle. So 8 over 3 pi, take away 4 root 3. Lovely. Okay, the next bit going to be a bit complicated. So what we've got here for this bit, we've got 2 sectors, and then for each of them we've got to take away segments, and we've got 4 segments to take away. So 2 sectors minus 4 segments. So 2 lots of the sectors. A sector is 8 pi over 3, which means it's 16 pi over 3, or 16 over 3 pi. I'm so glad this question says leave it in terms of pi, because this could get nasty. Take away 4 lots of that segment, and the segment is 8 over 3 pi, take away 4 root 3. Now we need to expand that. 16 over 3 pi, take away 4 times 8, 32 over 3 pi. And then this is going to turn into a plus 16 root 3. I'm going to get a negative from here. Actually, this is going to work out quite nicely. 16 take away 32 is negative 16. So 16 root 3 take away 16 over 3 pi. And that's everything I need to do. I'm not going to factorize it. I'm just going to leave it like that. And that's the paper done. Good luck for your exams. Keep liking, keep subscribing, keep watching, and I'll see you next time. Bye-bye.